In this paper, we propose a simulation-based robot testing framework that uses the property-based testing paradigm. Our framework is based on 4 main components. For each action that we want to test, we encode properties that define the action's success and parameters that are needed for verifying each property. This information is encoded in an ontology. To ensure test flexibility, we parameterize tests using a configuration file that defines parameters such as the possible worlds in which the robot can be tested or the objects that can be used in the tests. Using the information from the configuration file, we generate test scenarios and verify the action properties after the execution of each respective action in a test scenario. The results of the tests are used to generate test reports, which can be used for analyzing the tests and potentially for identifying the reasons for encountered failures. We investigate our framework by testing the Toyota human support robot in a Gazebo simulation. In this particular case, the robot is tested in a pick-and-place task in which it first has to approach the table, then find an object to pick there, subsequently pick the object, and finally place it back at another location on the table. The table used for manipulation, the object to be picked, as well as the different distractor objects in the scenario are all configurable parameters. Here, 17 different properties are verified for the tested actions, such as whether the robot has collided with objects while picking, or whether the desired object has been lifted from the table. Our work represents only a preliminary step towards the use of simulation-based property-based tests for robot testing. Some ways in which our framework can be expanded include enhancing the test parameterization, for instance so that the physical parameters of objects can be varied, expanding the framework to scenarios more varied than tabletop manipulation, and using the results of the generated test reports for automatic simulation-based learning and policy improvement.